Hello and welcome to another episode of Virtual Coffee with Ashish for Cloud Security Podcast. And this is a continuation of our Kubernetes month. And today we're talking about how to do a risk analysis of Kubernetes. Well, or to simply put, how to ask questions for a risk analysis of a Kubernetes cluster without sounding like an idiot. I guess that's my way of putting it. I have a great guest for this, but as always, I have someone to thank for, which makes these things happen. So thank you, Exonius. And I have Nate here to kind of tell us how amazing the team over there is.
Hey, Ashish and Cloud Security Podcast listeners. Thanks for giving Exonius the opportunity to sponsor the show. Exonius does exactly three things. By connecting to existing data sources, Exonius gives customers a comprehensive asset inventory, both cloud and on-prem. It then uncovers security gaps, and finally, it automatically validates and enforces policies. Thanks again, and check us out at exonius.com.
Awesome. So thank you, Nathan, and thank you, Exonius, for continuing to support the show. So without further ado, let me get the music going. Welcome, Mark. How are you, man?
I'm good. How are you?
Good. Thanks for coming on, man. I think it's always good to have more people actually who are in the Kubernetes space sharing and caring. So I'm so glad I have you here now. And hopefully you can help me not sound like an idiot when I'm doing a risk analysis of a Kubernetes cluster and asking the right question. So hopefully we can get there. But there is a tradition in the stream that we have. Cheers, by the way.
Yeah. Cheers.
Thanks for coming for the coffee, man.
Yeah.
Oh, I don't think you're having coffee, are you? You're like, what are you having?
This is actually coffee. Like at the end of the day, I'll have some coffee, and so this is my time to get into some technical stuff again. So yeah, I'll ramp up on some coffee. What are you drinking? You drink coffee?
Yeah, I'm actually definitely so because most of the guests that I've had, they've obviously been in different time zones and day before. So they usually go for beer, whiskey, but it's good to meet another person with a beard and drinking coffee in the night as well.
Did we just become best friends? I feel like this is
I totally feel we became best friends right there, man. Awesome. But I think we're going to be becoming even more closer once we teach a few people about Kubernetes as well. So I'm going to start off with the obvious, but for people who don't know Mark Manning, can you tell us a bit about yourself and how'd you land where you are today professionally?
Yeah, so I've been kind of like self-identified as like a hacker, kind of growing up, and I wanted to get involved in like the DEF CON scene in the US and hang out with a whole bunch of, kids in hoodies and things. And that was the thing that taught me that I wanted to do this in my career once I realized that there was a career. So I worked with companies like Intrepidus Group and NCC Group, and they taught me a lot about doing network security penetration tests, red team assessments, application security assessments, source code reviews. So I've had 10 or 15 years doing that type of consulting work, and then recently I moved over to being a security architect at Snowflake, where I'm kind of trying to actually see if I can do some of the stuff that I've been complaining about all this time, like, all this stuff's broken and, you need to go fix it. Now it's like, I'm the person who needs to go fix it. Let me see if I can sort that out.
No, nothing wrong with sorting out stuff from other people as well, and especially from things you've learned. I was going to ask, in terms of, let's just say Kubernetes security, what is Kubernetes security, or what is Kubernetes according to you, and what is Kubernetes security?
So like overall, like it's really hard to like define like the whole Kubernetes ecosystem. Like when I was working at NCC Group, we had this group of people that was working on Kubernetes. What that meant was we worked on a little bit of Kubernetes stuff, which is the Kubernetes API. It orchestrates a bunch of containers. It runs a bunch of services on this platform, things we could do forever. But really, Kubernetes to me represents like this entire ecosystem of being able to set up load balancers, being able to set up north-south network controls, being able to do service mesh, all this kind of stuff. It just happens to be this platform, this orchestration platform is this standard API that you can communicate on.
Oh my God.
Yeah, I don't know, like to secure this whole thing, really the takeaway was like, you've got to secure all the different components and you got to understand where the components are. This is why like you can't just secure Kubernetes. It's, you also have Istio, you also have this proxy, you also have this, other thing that's doing something else. You got to get a hold of all that stuff to really, truly understand what it needs to do.
If anyone wants to understand the depth of the platform, I think the CNCF has that image, which is like hundreds of applications.
Yeah.
If you want to have a nightmare of what this, how big this space has become, is like that screenshot for me is like, I don't know, hundreds of applications, and Kubernetes is one of them.
Yeah, they just I saw they just added 19 more or something like that. All the cloud native applications, they just go through the CNCF and start saying like, hey, help support me, help get some people behind me, and like, wow, it's huge.
It is massive. And maybe one way to kind of talk about risk analysis and how to kind of take this would be, what are some of the common components of Kubernetes that people should be aware of?
Yeah, so it's like at the base level, we talk about Kubernetes as clusters, right? Like there's a Kubernetes cluster. Usually you've got a bunch of things running in it. So there's the cluster, there's the idea of a node, which is just basically, you can think of it as a server or like one of the components of the cluster. And then you start getting into what they call pods, which are just a group of containers that are running in those things. And then on top of that, there's all these different controls, but those are the primitives, cluster, node, and pod, and everything else is kind of YAML abstractions from there.
All right. And people talk about control plane, API. What are those?
Yeah, when you say like Kubernetes, it's like a whole bunch of just processes, right? There's a whole bunch of programs that are running in the background, and they think of them as the control plane, the Kubernetes API, the networking components that need to go in from how to interface with the API, how do you port forward through different components on a node. For example, you've got this main control plane, but you've got a bunch of nodes, maybe on an EC2 instance, just somewhere out there, and you want to be able to forward a port to one of those random nodes on some place. You don't need to know where it is, and that happens through the control plane. So there has to be all these proxy systems that are communicating from the control plane down to the nodes and back and forth, and a bunch of observability stuff is happening in between there. So there's this control plane that's designed to be like locked down. Like you're not supposed to do anything in here. There's a bunch of privileged stuff. Like this is the main kind of kernel, if you will, of the operating system. Like this is the guts of the Kubernetes platform. Oh,
interesting. And then, because I think to your point, there's so many moving parts to it as well because of that whole distributed system background as well. It's funny, I was going to ask you this question, but Vinit's already asked me the question over here. As a newbie in Kubernetes, what advice do you suggest for risk analysis? So keeping that question in mind, where does one start doing risk analysis? Like what's the kind of questions that I'm asking when I'm starting risk analysis?
Yeah, it's like the worst case scenario that I've seen is like, when I was consulting for some of this stuff, it would be organizations that just had Kubernetes pop up for themselves, right? And they're just like, I need to understand the risk of this thing. It's my job to secure it, but I don't know what Kubernetes is. I don't know where it is. I don't know who's running this thing. So there's some like basic primitives of like, where are your clusters? It's like, it sounds like a simple question, but is it hosted in the cloud? Is it hosted, locally? All those things are different threat models. And I think that contributes to it. How big the clusters are, like when you go and like, what's the attack vectors of this stuff? Like how many people can actually get into your Kubernetes cluster? How many people can access the thing? Who's running it? Who has access to control anything? Who has access to deploy different stuff into it? So it's like the who, how, when, and all the kind of questions.
Oh,
how do you get a handle on the entire like Kubernetes platform before you can start doing risk analysis on it?
So sounds like the cluster is probably the more, I guess, the more core of it, the core of the system as well. So when people are looking at the risk analysis of a Kubernetes environment, I guess they're obviously finding out how many clusters would you have, and would you want to? Is there a way you kind of start by assessing a risk of a cluster per se, or is it more like that's kind of where you go? Hey, who can deploy it? The authentication, authorization, and the kind of like what are your thoughts on that?
Oh yeah, I think I'll start at the cluster level. Like most organizations have like a single cluster. I'll say like most, and like there's a primary production cluster, right? Like that's usually like a model that's pretty common. And you go, okay, I'm going to focus all my attention on that. So you think of like, okay, what access controls do I have in that? Who has access to prod?
Right.
How do they access it? Because the question is, do I give my developers access to the console, like with kubectl, so they can directly push things into the cluster directly from their laptops? That seems kind of scary. Or some organizations, they'll do things like, I'm going to grant SSH access to each of the the pods that you deploy into these Kubernetes, and that's scary in itself. Like, how do you manage any of that stuff? So the access control thing, it gets heavy when you have like the scale of stuff, right? Like, when you go like, I've got 3,000 developers and they're all in this thing. How do I tame them? How do I ensure that they're only accessing the stuff they need to? So I think that's step one for me.
Wow. So wait, production with kubectl access to pods in a cluster, but the number could be like 3,000 plus people accessing the.
I've seen it all, man. Like, I've seen like all kinds of, like, you would never really want that realistically, right? But
yeah,
well, I got to go debug this thing in production, so I need to have SSH access, or the operators will be like, if this thing crashes, I need to go figure out what's going on, so I need kubectl. So it's in my ideal world, like, you never allow direct access. There's always like the break glass scenario where you go,
yep,
something terrible is happening. We got to get in there. We got to do some stuff. But most of the time, developers shouldn't have access to your production environment. Like, that's just a universal InfoSec truth, right?
Yeah, but maybe let's just peel it off in a different way. So I guess maybe we can start off with what's a good deployment structure according to you, and then we can go into I guess a bit more defaults now. What do you think is a good one to start off with? So at least anyone who's listening to this and wants to do a risk analysis, at least they have a picture in their mind for, this is what a good one looks like. This is what a bad one looks like.
Okay. The best one that I've ever seen, they abstracted away access completely. So a developer needs to access, needs to deploy, like an Nginx service or something into Kubernetes. They'll push something to like GitHub, and they'll have some kind of layer on there that says, here's how I want it to look inside of Kubernetes. They can use some kind of like CD system, right? But there's the developers never have direct access to push into Kubernetes. It's just using CD, using CI/CD, and just deploying the application into the place that it needs to go. And then you're relying on like support teams to help make sure that it's actually running there. But those are the ideals.
So if I were to unpack that example a bit more, if I have an Nginx application, it's a CI/CD pipeline that's making the package, and when the package is ready towards the end, it'll make an API called the Kubernetes API, or kubectl, if you want to use that, it'll use that to deploy into the cluster instead of logging in. I want to SSH into it so I can deploy my Nginx box.
Yeah, exactly. I mean, yeah, we laugh, but like that happens all the time because it's just so much easier. Yeah, something like GitLab, right? Like GitLab has support for this, right? You just go like configure it and say, what's my cluster? And then when you need to grant access to stuff, you're not doing it to all of your developers. You're saying like, here's my GitLab service, here's my repo. I'm going to grant that thing access to my cluster instead of everybody in the whole organization.
Oh, and we've already spoken about the bad scenario about direct SSH access. Are there other anti-patterns for like that risk analysis people can look for?
From the authentication standpoint, like access controls, there's a lot of like there's a lot of like extra ways you can get back in there. Like with kubectl, you can also do like port forwarding. So what I've seen is like they'll have in like a little sidecar, which means like you've got your Nginx instance, but then you'll have like a debug pod like sitting next to it at all times. So sometimes you'll see things like it'll run like an admin console that you can kind of like log into as a backdoor to the system, or maybe it's running SSH and stuff. So there's a lot of like sketchy ways that you can kind of backdoor your system to grant access. So
so I don't access directly, but I access to the backdoor that I just left over there.
Yeah, exactly right.
Like, hey, I'm not. I did what Mark said. Don't log in directly. I just leave a backdoor. Exactly. And I think this kind of goes into the next step as well. So what are some of the security defaults that people should be looking for? So clearly you've pointed out authentication authorization already. Are there other components as well that are like low-hanging fruits?
The biggest thing is like the runtime security as a whole, because the problem is like, I do these talks and I beat up on Kubernetes, and it's really not Kubernetes that's at fault for most of the security issues. It's just that we've chosen these insecure, designs, or we've done something that we didn't realize has security impacts. So I think a lot of organizations will go into and just try to secure the runtime. And they do that with things like OPA Gatekeeper is a thing that does like policy controls over things like, okay, I'm not going to run privileged pods. which is if you run a privileged pods, it basically means like I've disabled all of the security for the container. Or I'm not going to run as the root user, meaning like you're not going to use any permissions or all that kind of stuff. There's also constraints you can do of like I don't want to ever allow host mounts, because if you can have a pod that mounts like the host operating system inside of it, you just can take over the host operating system. I did this all the time. Like
so you can break out of the container.
Yeah, you don't even need to break out of the container. That's the best part of it. Is like if you mounted the root of the host operating system, if it's Linux, right?
Oh,
you mount it inside of the container. From inside the container, you can just like root that environment, and like you now are the host. Like, but you're not breaking out of the container. You're just
that's right. Kind of like, I guess for old school people, it's a virtual machine which you give access to a drive on the host.
Yeah,
but you're not on the host, but you actually have access to the host.
Exactly.
Oh, actually, that kind of takes me to this question that Vineet has asked over here. How do you list inventory of a cluster? Is there like an API command on Kubernetes for this?
Yeah, I mean, one of the first things we ran is like kubectl, like dump cluster, or if I think cluster info dump will just extract everything. Like here's all the YAML, here's all the things to process it, and you'll see everything there. Whether or not you can really understand what's going on is the second thing. But Kubernetes is a pretty decent API to just say like kubectl get deployments, kubectl get pods, get namespaces, and all that stuff will give you a pretty decent inventory of what's running in your cluster.
Right, and so hopefully that answers your question, Vineet. But I think Kubernetes API is mature enough that it understands there would be requirements for these. But I think that to your point, the challenge could be understanding the information that's being given in front of you.
To say that like that's a true inventory, like that's collecting the information. Like having an inventory, which would be like actually itemizing, what the intent of each one is. Like that's a harder one. And there's a lot of like third-party tools that I think attempt to do that. A lot of like cloud providers are attempting to make that as a service, right? You go in like, here's your inventory of everything that's running.
All right. Yes, I think we answered this question. So that's pretty awesome. I think I was going to ask you then, so we kind of spoke about what an ideal, deployment flow for Kubernetes could be. But I just keep thinking, because when I think about scaling security, and I think about, having some kind of defaults, which say, okay, if I have these defaults, because in a lot of people have been taught by cloud to automate everything and have some kind of sensible defaults that they can go for, because then you can scale easily as security. Are there things like that people can actually find out? Well,
I think more importantly, you need to have like a runtime policy. And that's kind of what I was trying to explain before, is like, as an organization, you need to define exactly what you allow your developers to do, because Kubernetes allows you to do whatever you want, or it allows you to restrict what you want. So like a developer is going to say, I need to run this pod as root, I need to run as privileged, and you need to have a system that can tell them like, no, you shouldn't do this because it's actually going to hurt you. It's not about the system. It's like, you shouldn't do this because you're gonna kill yourself. And also, here's the reason why, or here's some feedback. And that's why I really like some of the OPA stuff, which is the Open Policy Agent, which is trying to provide like not just like it's kind of like a platform of you shouldn't do this, don't run as root, don't run as privileged, don't whatever the organization wants, put it in a policy, and then it kind of gives developers guidelines that says, okay, you can't do this, but then also like the feedback on why it didn't get deployed was customizable, so you can say like, here's per this policy or whatever reason, like you can kind of give them something actionable about like what they need to fix.
So the more we're going deeper into this, I'm really enjoying this conversation as well, because we kind of started off with the cluster. Like the most important part is to figure out what cluster you have and how many clusters you have. Then you kind of go into what's a good cluster should look like, and what's a bad one looks like. So that was good as well. And we kind of spoke about some of the defaults, but I think to your point, sounds like a lot, and I think you started off this conversation by saying this as well. Sounds like a person who's trying to do some risk analysis on the Kubernetes cluster need to have at least some basic understanding of Kubernetes. It's not just as simple as I'm going to go in and ask a bunch of questions because I've had 20 plus years of doing security risk analysis. I can use that information. Is that what you feel as well?
That's what it's even more than that. Like I was that person that came in with, that background in network security and thinking like, oh yeah, I know everything about Kubernetes. And then I went, whoa, this is a different beast. So yeah, I 100% agree that like you have to treat it with something else. You have to appreciate what it's trying to do. You have to appreciate, like, number one, there's no like IP addresses. Like if you throw that right out the window, all the NetSec folks that I used to work with would always be like trying to nmap my Kubernetes cluster. And I'm like, this doesn't make any sense. Like everything is ephemeral. It lasts for 10 minutes to like an hour. I don't care about their IP addresses when you give me a pen test report. I need to understand like what the service is doing, that kind of thing.
Wait, tell me more. So there is no IP address?
There's totally IP addresses, but like if you imagine like when I was working as a security consultant, I would give like a pen test report, a classic like nmap, nested.
Yep, first step recon. Yep.
You might be like, yeah, okay, I found this host. Here's this IP address of this host. They're running an outdated Nginx. And then you turn to the customer and they go, oh, here's this IP address. And then you go look it up in your system and we're like, that's an IP address that doesn't exist anymore, or it's not even relevant. Like we burned down that cluster, because Kubernetes really operates so ephemerally that you can't really assume that like the same IP address is going to be the same thing. You can't even assume like the same host name a lot of the time. So you have to really understand like the Kubernetes identifiers and get deep into the service to provide any like actionable perspective on that stuff.
Holy shit. So, okay. So at least we clarified that part, that you definitely need to have some respect of the platform and understand it a bit more. And it's the ephemeral nature of the Kubernetes platform that attracts people, because it's abstracted so much of it that I feel, I think that would definitely make a difference at that point. Is there a supply chain element in there? I think you touched on CI/CD earlier. Is there a supply chain element on how can that be exploited?
Yeah, 100%. Like I think all the stuff that normally goes into a Kubernetes cluster comes from, your artifact store, or it comes from an image registry, right? And these are all things that are hopefully built within your organization and things you got to lock down. So like this is thinking about supply chain. You've got to think about the images that are getting deployed. Like where did they come from? Did they come from Docker Hub? Because that's the wrong answer. They come from some external GCR repo. Like, it's tough. And even if you've chosen, like I'm going to have a private image repo for my org, right? How do you actually verify that the stuff that you've built is actually trusted, within your organization? How do you know that like your build environment didn't just go out to Docker Hub, pull down Ubuntu and bake it in there? Like, we're just kind of shifting it in a direction. So they're doing a lot of work on like, with Harbor is a container image registry. Right. Docker Notary 2 is coming out with like different ways of signing images, so you can kind of verify the integrity throughout the process. But yeah, the whole supply chain going into Kubernetes is tough. But
I think that reminded me of I can't remember which a couple of years ago, exact same scenario. But we were working on ECS on AWS container services, and someone's talking about containers and like, oh yeah, we use our own private containers, but the source was in Docker Hub.
Exactly.
They download the Docker Hub container, add a bunch of stuff in it, remove a bunch of stuff in it, and then, hey, it's our container. But it happens every time. Oh my God. Oh, that brings back memories now.
And it's still like, there's still so many organizations that are doing that. And it's still like slightly like a step up from just straight from Docker Hub, so that you don't have like the denial of service issues now, since Docker Hub is like rate limited everything now. So there's this narrative like, oops, I'm going to get blocked by Docker Hub from like pulling down my images. Now I can't even deploy into my production cluster. Like that's super.
So now you have to localize it. That could be a totally different rabbit hole, but I'm going to stop myself there and go to some of the questions that have come through as well. Magno has asked, hey Magno, good to have you again. How do you analyze a cluster RBAC, and how can we ensure that cluster admins are implementing it properly and securely?
Magno knows some poignant questions here. Yeah, this is so like the RBAC stuff is really interesting. One thing that we do like in the current company is we'll do reviews of a new application that goes into a Kubernetes cluster, right? But we'll do an assessment too on any RBAC controls, meaning like, what does the application need to have access to? like we want to be able to keep track of logs, but like why does this service account need to get an RBAC profile to like connect to the Kubernetes API? Like it doesn't need to do that. Why does it need to access secrets? It doesn't need to do that. I've used kubectl crew is a plugin system. It has it's like the pip for kubectl, if you've ever seen this stuff.
Oh, right,
Yeah. Packages, and you go in pull some of the stuff. So there's RBAC view. There's a bunch of I think it's just called crew access controls that it dumps exactly who can access what.
Right.
And it'll say like who can access secrets, who can in this namespace, who can look at all this kind of stuff in this namespace. But I wrote a blog post on, if you search for NCC group RBAC, there's a blog post that I wrote a couple of years ago about the kind of the state of all the different tools that are out there. And like for me, it was about visualizing it, because I've got 3,000 devs or whatever, how many applications, and I really need to understand how each of them are able to access each other. So I think the kubectl crew is the way to go.
Kubectl crew. I'll leave the blog post in the show notes as well. Hopefully that answered your question, Magno. I've got a question from Miplov. Do you suggest any tool other than kubectl which can detect these security misconfigurations?
So there's a lot of new tools that are kind of coming out to like auto scan. Like there's a bunch of, what I really like is there's a bunch of tools that help you like exploit Kubernetes clusters now. So they're just almost like the Metasploit of. Oh
yeah, I was going to say Metasploit, yes.
Yeah. So like the kubesploit stuff, and like there's Pirates is made by Jay Beal and Guardians, like that's designed to do like attacking and stuff like that. But to the question of like scanning and finding things, there's tools out there like kubescan, and there's another one that Rory McCune wrote that tries to like compare it against CIS benchmarks and say like, here's some vulnerabilities, here's some feedback. And the only thing I'll warn you on that is somebody that's just been doing this forever and trying to find those vulnerabilities, is like they can give you like perspective for sure, like you should run them all, but they might not understand the context of your cluster, and two, they might give you like a false sense of like belief, because like, oh, I ran through the scan and like it says everything's good, and it doesn't have anything for Istio or Envoy or whatever your CNI is for network controls. Like, there's just so many pieces that I don't really want to be like, yeah, I can just run this tool and you're all good. But the CIS benchmarks tools are what everybody uses.
Wait, what are your thoughts on the CIS benchmark, out of curiosity? Because I think coming from a cloud world, I kind of have a mixed opinion of CIS, which they never updated after the first version. So it never matured to the scale the cloud kind of grew up to. Is that the kind of state that Kubernetes is in, or CIS in Kubernetes is pretty awesome?
CIS in Kubernetes is probably the most awesome CIS there is.
This is the only one, yeah.
So shout out to like Rory, who manages the CIS benchmarks that I know, and like he's done a lot of work to keep them up to date and keep them relevant, and they're definitely on point, and like they are. They're expanding on this kind of stuff, and they even have flavors of CIS benchmarks now. So there's a GKE benchmark aside from the Kubernetes benchmark. So you now can specifically not just be like, well, I'm running GKE. They have different expectations than my standard Kubernetes and things like that. So they're good. Okay, so that's the most charitable it can be, but we all know that like they have inherent weaknesses that like if you rely on them alone to like dictate how you do things in your cluster, that's not what they're designed for. They should be kind of feedback, give you some insight, and then you got to go figure out the rest, right? You got to go figure out like it's not going to tell you about Istio, it's not going to tell you about Calico, it's not going to tell you about your eBPF you've installed, or your sysdig Falco rules, or it doesn't understand any of that stuff. And that's the point. It's like Kubernetes is this ecosystem of a whole bunch of other stuff. You've got to get a hold on everything best you can.
So learn about Kubernetes first, and then look at CIS benchmark. And okay, a great place to start. Great, all right, great answer as well. Magno has another one. The problem with admission control is that that it only prevents when the container is being deployed. But what happens after the container is running? Is runtime protection the only way? Again,
Magno knows what's up. Yeah, there's this thing like, so admission controller, just to understand the question, like the admission controller model right now, and this is kind of why pod security policies were given up on, or one of the reasons, is the way that it works is you give it some YAML. It says, I want an Nginx service. It says, cool, here's my structure, my deployment, all this kind of stuff. And then the admission controller, usually like you can have an admission controller of like OPA or a pod security policy admission controller. And they go in and they review your YAML. And they say,
Yep.
okay, this YAML looks legit, like everything's cool, like, and it's literally the API is like yes or no. It's like a true or false, just go. Like that's the only feedback you get. And then it's just released into the world. And there's some subtle things where you go, that one of the features is allow privilege escalation in a Kubernetes pod. Like,
wait, does it say allow that? I thought you just made it up.
No, it's called allow privilege escalation, and like any security person's go like, no, don't allow priv esc in my system. But it's designed really means like pseudo, right? Like it's saying like, do you want a normal user to become a different user or assume a different UID? So there's so it's saying like, do you want to allow pseudo? And in that case, like there's a scenario where, okay, I'm not running as root, right? Maybe I'm running as a different UID 1000. And that passes the admission controller and says, yeah, admission controller says you're running as non-root, everything looks legit, I'm going to pass it on. And then once it gets deployed out there, you go, okay, I'm going to shell in, and then I'm going to run sudo, turn into UID 0, turn into root. And then I've now bypassed like the original intent of the policy right before that. So all those admission controllers, they stop right at the beginning. They go, okay, I checked this out, everything's good, wash my hands of it. And there's nothing to go back and monitor. Like, did anything change? Did anything get updated or modified? Is there anything that got like manipulated with a patch? Like, have we seen any of that stuff? So that's why like Sysdig and a bunch of other organizations are trying to do like constant runtime security checks on top of admission controllers.
Oh, because that's an interesting one as well, in terms of a lot of people kind of go down with the sidecar model of monitoring pods and containers and stuff as well. And I guess, is that the only way that, or have you seen like a better way of doing it? Like, as in, I don't know, what's a better way, I guess, if there is one? There's
a bunch of cool ways, like from just like an auditing perspective, like the eBPF stuff, I'm really into. Like the Sysdig Falco has kind of like two modes, for example. Like you can do eBPF mode, or you can do Linux kernel module mode, which are just done like, they're both just at each node, they're monitoring stuff on your behalf, and they're keeping track of all your containers, as opposed to like needing to attach a sidecar to every single process and like see what's going on with all that kind of stuff. I think that's the more modern approach to most of the observability stuff.
Interesting. And by the way, just to your comment earlier about pod security policy, I think Viplav had another comment. What are your thoughts on pod security policy? I guess they work in some contexts, not in others, I guess. It's a short answer, but you can expand again if you want to add any more bits in there.
So pod security policies are dead, and they've been replaced with, I think, like pod security guidelines. I'm sorry, I'm not up to date on the latest. They just changed this recently. So the issue is there's this new version where we're going to go out and we're going to say, okay, pod security policies are gone. And then there's going to be a version where we don't have any pod security policies and we don't really have any replacements, because there'll be this alpha testing API.
Oh, right.
In about 2 versions after that, we'll have a kind of replacement to a pod security policy that addresses a lot of the stuff that's there. My perspective is what I've been already telling customers for years. When I was giving consultations, just like go straight to OPA, because if you look at like AKS, like Azure's Kubernetes, they've given up on pod security policies, and they say you can't even run any of them, and they've done everything with OPA like built into it. So OPA seems to be the way forward. OPA, usually the combination is OPA plus OPA Gateway or OPA Gatekeeper plus this OPA constraints framework, which basically is a drop-in replacement for pod security policies. Does the exact same functionality. So I've all but given up on them, and I don't want to give any recommendations one way or another.
Yeah, I think Magna agrees with you as well.
Yeah,
I was going to say Magna agrees with you as well. PSP is being deprecated. Check out OPA, or I don't even know how do you say this. Kyverno?
Kyverno. There's also K-Rail. There's a couple of them that are just like replacements to pod security policies. Just give us like those guide rails of here's exactly how you're supposed to run stuff.
Oh, wow. There you go. So hopefully then that means risk analysis job is going to be easy as well. Just go to one of these, make sure the OPA policies are checked in, I guess. So that makes me kind of go, if I'm looking at, so we kind of spoke about a few elements as you're doing a risk analysis of the Kubernetes clusters. But as you've already pointed out, 3,000 devs, one cluster, but there could be scenarios where that's one scenario, but there could be a scenario where you can go down the whole cloud model and go one cluster per business unit and however many teams that came in there.
Yeah.
How does security kind of work in that scale? Like maybe how would you do a risk analysis of that? And is there a way to secure that? Like what's the way to, I don't know,
The coolest,
scale it?
Yeah. No, the coolest organization I've seen do that was like they had like a control plane for their Kubernetes clusters. It was actually like they're running a Kubernetes cluster that would build Kubernetes clusters for them. So it would be like this declarative thing because they believed that every single business unit, like you're saying, should have their own Kubernetes cluster. But even better than that, they were like, they should be able to tear it up and rebuild it like whenever they want it. So they made this like abstraction from the whole thing and then said like, go to it. So
Ooh.
Yeah, so getting your handle on like, how do you audit that? What's the risk of that thing? Like, what are the guidelines that you provide? In the end, it gives you so much more control if you do that stuff, right? Because you're not saying, here, good luck, go build your own random Kubernetes cluster. You're saying like, I'm going to curate the perfect Kubernetes cluster on your behalf, and I'm going to just hand it off to you, So you get to choose all the runtime stuff that you want to do. Like at an organization level, you can just be like, well, we don't want anyone to run privileged pods, like the end, and try to work it out that way. So I think having more control is really what everyone's trying to get to. Like abstracting things away from users' control is the end goal.
Wow. So wait, because I always think multiple kube clusters means multiple Kubernetes APIs, means like the problem is much more scaled at that point.
Yeah.
And at that point, you kind of venture into the territory of, would you rather go for a managed Kubernetes in one of those cloud service providers, or would you go bare metal?
Yeah.
Or I don't know, cloud native or whatever. But what would you say your approach would be for if we were to go down that path?
Well, bare metal is, I haven't seen an organization do bare metal in a really long time because, actually, I take that back. There were some big name companies that were doing bare metal because they had the resources, they had giant teams to support it, they had all this like stuff around it to build this system. But bare metal is all but gone because of that reason. Like you need Kubernetes experts and geniuses to be able to make the system correctly because there's so many knobs that you can mess up that it's really easy to shoot yourself in the foot. So everything has been GKE. EKS, AKS. There's been like, if you look at some of like the OpenShift stuff, some of like the things that like Red Hat is doing is the only way in my mind to like sanely deploy Kubernetes today. Like doing it from scratch is fun and dangerous and super hard, but should never like end up in production.
At the risk of the person who made it leaving the organization. And basically leaving you hanging dry, I guess, 100%. Oh my God. I think I definitely find that to be a piece where it's great if you have resources, but then again, those resources may choose to move out of the company. Then what do you do?
Yeah. But and also look at just like the stuff that GKE is doing in particular, like they're really making like one of the most secure Kubernetes flavors out there by like adding in like binary authorization control, which like lets you really like control the stuff that's in and allowed to get executed inside of your cluster. Like all this stuff that you just do not have the capability to run. You'd have to write it from scratch or try to rely on some open source stuff. It's just like, bam, it's there. Yes, it costs money, but bam, it's there.
Oh, right. Oh, so do you reckon GKE has a much more mature, compared to say AWS offerings or Azure offerings? Do you feel GKE is more security forward thinking?
I think it is now. Like I think Borg came out, turned kind of into Kubernetes. Like Google originally released Kubernetes, and then AWS kind of came in and like dunked on them, and they came in and they were like, I'm going to take Kubernetes and I'm going to make EKS. And at that time, that was an amazing service. And like GKE just didn't match up. But now I think like the current state of it is like there's so much more extra features that Google has bolted on to GKE like as a support system. Like if you just look at the Kubernetes portion, like EKS, GKE are about the same. But some of the capabilities, in my opinion, that Google provides over EKS is by far more secure. But I think I'm kind of biased.
No, nothing wrong with that, but at least it's good to know the overall landscape as well. Like if it started well with EKS and now GKE is taking on the race, you kind of hope so, considering they started the thing almost 15 years ago. So it's good that they're catching up. I've got a couple of more comments in. Viplov is asking, isn't Rancher used to manage the Kubernetes cluster? Rancher is another platform, but what are your thoughts?
I thought Rancher, they kind of like pivoted. I think they got bought out by SUSE Linux or something like that. But what I've seen Rancher for is like the K3S stuff. I don't know if you've seen any of that. It's like a minimized version of Kubernetes.
Like a mini cube, like a cube mini or whatever it's called.
Yeah. Kind of it is in the same way of Minikube, but it's also designed to do like, okay, I want to do maybe a small Kubernetes cluster on a bunch of Raspberry Pis. You can use K3S because it's got a lower resource footprint. Oh, maybe I want to run Kubernetes on like some like edge system or some IoT, like whatever it is. Like it's just so much more lower profile, so you can do the same kind of level of orchestration. And that's what I saw Rancher was doing to go in that direction. It's a really cool pivot. I hope they.
Yeah, smart play from them, I guess, because they definitely were. I mean, yeah, I'm not gonna go into that. I'm gonna give another rabbit hole that I want to avoid. I've got a question, actually a good one from Nanika as well. So many good questions today. Apologies if you have already covered this. What's your opinion on threat modeling versus performing a risk analysis, especially if this analysis has been performed by the dev team? We haven't covered this question, Nanika, so great question.
Yeah, that's an awesome one. I mean, so like my take is, at Snowflake, I do a lot of risk analysis as a security architect where it's designed to be, I need to determine the risk of whatever we're trying to do, and then also like mitigation packages for it, right? Like I go, okay, I want to do XYZ in Kubernetes. I need to understand the threats. I need to understand the attack vectors. I need to understand like the overall like impact and that kind of stuff. And then once we get into like the development stages and the engineering stages, that's actually when we do more threat modeling. And it's like it's a subtle difference between threat modeling and risk analysis kind of stuff. But like risk analysis is usually like business impact factoring in pretty heavy, looking at like assets you're trying to protect, versus like threat modeling is super useful when you've already got the system there and you go, let's just see like how successful we are at defending from these threats. So I'm biased, like I work in security, do both, right? Like, but it depends on like what phase of maturity you're in, I guess.
Right. And have you seen one run with devs on Kubernetes, like a threat model being run on Kubernetes by that? Have you seen that?
Oh yeah. I mean, you have to factor it in, like, and I think this is like maybe to the point of it's important to understand that the Kubernetes world and the DevOps world really focus on a lot more control for developers. And that's important.
Right.
We need to like sympathize with that, but also we need to understand them as a risk, right? Like we just need to factor them in. That doesn't mean that they're nefarious, but when we're doing a risk analysis, we have to say like, a developer going in, SSHing into, your Kubernetes cluster is a risk. Doing stuff from a laptop is a risk. So I think you have to factor that in.
Yeah, appreciate that. And it's and I think she has got a follow up on saying introducing the culture of our challenges. What methodology would you recommend for performing risk analysis for Kubernetes? I think we've covered the initial part, but culture of running analysis in an SDLC is. I'd love to hear your comment on that.
The thing that I'm into lately for risk analysis has been usually like a mixture of the Magoo system. If you've seen this stuff, if you search for like Magoo risk analysis, he's got kind of really.
How do you spell that?
MEGOO.
All right. Okay. I'll put that in the show notes as well. Yep.
And he makes kind of like a short, kind of concise version of how to do risk analysis stuff. And then the other one that really is like more formalized is called Engineering Trustworthy Systems. is like the Bible of doing risk analysis that I kind of have been following and believe in. So like those are how to do it. The culture part, like, man, that's really tough, right? Like how to get people to accept this stuff. But like Snowflake has been really good at this actually in reality, because we do the product security team before I came there started like a developer driven security program that was designed to be like, look, we've got a security team, but they're not doing any of the security. It's all you guys, you're the developers. And we helped to make sure that all of them understand how to threat model, how to define the threats and risks for each of their environments. And they do that for each of the applications that go into Kubernetes clusters, right? Like analyze the risks of this stuff, and then we'll do security reviews on them and threat model them. And like, it's all part of a program. But I don't know how they got that culture, but they've had it there for a while, but they've successfully convinced them all that culture is important.
Awesome. That's a great answer as well. Hopefully that answered your question, Danica, but feel free to answer if you have more. Feel free to ask another question if you have one. I've got one from Magno as well. Clearly, he's giving you some solid questions as well, kind of like what Danica did. What do you think about drift detection? Do you think it's a good approach to identify any suspicious cluster changes? Which tools do you recommend?
I don't do any drift detection stuff right now. Like I have not been successful at doing any of the drift detection stuff is what I'll say. I'm totally supportive of it, and I haven't done any assessments of any organizations that are using it right now. So I'll just say that's out of my pay grade.
Oh, out of the pay grade. I was gonna say with the drift changes, is there open source tools that you know of already, or I guess Magno can share them some if he knows as well. But do you know of any open source tools? Is that even a thing in drift? Like, because
yeah,
you look after the.
I know Magno is smart, so I'd be interested in his feedback if he's got some ideas.
Yeah, I'll let Magno drop in.
Yeah,
because so would I be right at least to I guess peel that one more layer for people? Drift detection, would that be the change in the deployment config versus what's in the cluster, or would that be more someone has click opted?
Yeah, like similar to the previous question, just like understanding the current state versus the proposed state, right? Like understanding, like you have the same problem with like Terraform, right? Like here's this deployment. I go out and I've deployed it. Like how do I actually know that it's in the same state that I was actually expecting it to be? Like going back later and saying like, has anything been modified? Has it been updated, and doing kind of like diffs on stuff. Like you can analyze a diff between your your code that you deployed. Here's what I put into the system, and then what actually comes out is actually usually completely different, because there's all these things that get injected. Like maybe you've got an Istio sidecar that gets injected. Maybe you've got things that get extra bolted on there. So it's really hard to determine whether or not like it's still the same that you would expect.
Wow. Wait, I've got so many questions to ask you, man. But wait, I think as Magno's response, yes, I like someone install SSH on a pod or something like that. Comparing the YAMLs with the cluster. Oh yeah, all right, that would be the current cluster config. Yeah. It's funny. The reason I ask that is because the assumption people when they walk into a Kubernetes world is that, hey, you don't have everything's abstracted. You just define your deployment package, and Kubernetes API would take care of just deploying that whole thing, and it would remain reliability. It was number one, right? Like you almost go all these other tools that we kind of like shoved into it because of whatever it may be lacking initially, and people found an easier way. I feel like we've kind of pulled Kubernetes to some extent into the other things that we used to do with cloud and on-premise, where it's like there's a need for drift detection now, it feels like.
Yeah. No, I mean, I think Kubernetes provides an API, right? Like it's all much better than the cloud. It's so hard to really take an inventory of the cloud when you've got a giant environment, like everything, and saying that it's not drifting. Kubernetes has the opportunity of doing that, and that's like when I used to do this on every single like engagement that I did for Kubernetes. I would say like, why are you deploying Kubernetes? And some people would say things like, well, for performance reasons or like scalability, and like generally, like I haven't seen anybody like substantiate any of those claims. But I have seen the best answer, and this seems to be true, is when you want to do multi-cloud stuff and you don't care what cloud you want to deploy to, Kubernetes provides a way of doing most of the stuff you're doing in the cloud already, but like across any cloud. It's absolutely agnostic. It's a single API. You do it in the same way, GKE versus EKS versus AKS. There's subtle differences, of course, but like I think that's like the main selling point for Kubernetes. And like it's an opportunity for us, why it's like much harder in the cloud. Like if you happen to port it over to Kubernetes, it's much easier to do like drift detection in Kubernetes than it would be across your entire cloud or your fleet of systems.
Oh, actually, I don't know. No, that's a great point. So between GKE, AKE, and all this, I guess the three major cloud providers, the Kubernetes build, if I make it in, say, EKS, moving across to AKE or GKE is not that, like, not a lot of work, not a lot of hard work.
It's trivial. It's designed to be trivial, yeah. And then it's on the operators that manage like GKE and AKS for the organization to make sure that like the security kind of is in parity with each other. But you know, in terms of an API, it's almost a one-to-one. There's some differences between identity across the different ones and all this kind of stuff. But when you look at like, does this YAML work in this system versus this system? Like, yeah, you know, 9 times out of 10, it will without much manipulation at all.
Right. I've got another question from Magno, and probably the last one. But by the way, just a hint, Magno's coming next weekend. So if you're up and awake, definitely that's your payback opportunity. By the way, just say, Magno's question as well. So do you see Kubernetes being used for infra orchestration in the cloud, like what they're trying to do with cross-plane? What are your security concerns if that happens?
Yeah. When they just recently, or relatively recent, the last couple of years, they made like the cloud API for Kubernetes, which was like, I was so excited that we finally said, okay, you know, you look at where is the security boundary that you can really rely on in Kubernetes. It's not at the pod level. That's kind of mushy. There's somewhat at the node or the node pool level, like they're trying to do some stuff. But at the end of the day, like if I wanted to be absolutely sure that there's not going to be a hack, I would say it's at the cluster level. And then they started doing things where like, well, now we're going to allow inter-cluster communication, and like we're going to have multi-cluster Istio deployments and all this kind of stuff. So I think there's just a tool that just got released about trying to pull out all of the container stuff for Kubernetes and just make it like an orchestration platform as a whole. Like it could be for cloud components, it could be for running IoT boxes, it could be for whatever. It's just the orchestration part of Kubernetes, and then like throwing out the containers. And I think that might be where like the future of a lot of this stuff goes, is like just taking out the scalability of Kubernetes and that control API that they've done really well, and seeing where they can take it.
Interesting. Well, the Magnus asks you to be nice next week. Like, be nice, please be nice. So I guess the stage has been set from that perspective, but I'm going to take a pause from the questions of that. And I do want to, I guess, kind of like reel back. We've kind of spoken about a few things for risk analysis and quite a few changes that have happened. But one theme that I've taken away from all of this conversation is that if you're thinking of doing a risk analysis of Kubernetes cluster or deployment, you kind of need to get your hands dirty and at least to understand the terminology and what would get involved in it. So keeping that in mind, for people who may have listened in and gone, man, there's a lot of stuff to learn, where do you start, I guess, with learning? And what's your way that worked for you? And maybe some people can take inspiration from that as well to learn Kubernetes.
Yeah. I've been going into like the hands-on stuff from the beginning of still like Minikube. If you can set up like a VM that has Kubernetes, a lot of people are doing K3S. I mentioned, for if you've got an old Raspberry Pis hanging around, you can make a cluster for Kubernetes pretty easily. It's easy to set up. They even have like the K3 SUP, like it's a catch-up. It'll actually deploy automatically to your Raspberry Pis, all the K3S and like all this kind of stuff. So it's really easy to play around with this stuff. I would recommend that. There's the Kind tool, which is just like Minikube, but it does like, it's like Kubernetes in Docker. So it's actually like inside of a Docker container and does 90% of the stuff without having to have a virtual machine. So it's super nice for that kind of thing. And then, so like for me, it would be, I want to make my own unnecessary cluster. And then that's what I kept doing. Like, I don't need to run Kubernetes at my house, but I do it, you know, just for reasons to mess around with it and really appreciate, like, trying to do things in it. So I would go, I want to implement OPA with the constraints framework. I want to implement Istio. I want to implement some CNI. And you can do most of this stuff inside Minikubes, and that'll give you a feel for like the primitives of how everything is working together, in my opinion.
Wow. So all the 50 people who are watching across the stream right now, that's the answer for learning. Just start building it. Start building it. That's pretty much it. All right. This is the last segment of the podcast. And these are 3 fun questions. None of them technical, but hopefully not. And I've just to get to know you a bit more. So just going to quickly go through them as well. What do you spend most time on when you're not working on Kubernetes or technology?
Man, it's for me, it's been a bunch of zero trust stuff. Like it's still technology. Like there's like the family things that I do around the house and that kind of thing. But I have these 2 topics that I'm really focused on, which is Kubernetes, and the other thing is like understanding and appreciating zero trust and zero trust authentication stuff. So that's my other topic that I'm working hard on.
Oh, sounds like I might have to bring you on for zero trust as well someday. But I'm going to leave that for future. So next question. What is something that you're proud of but is not on your social media?
Yeah, I don't talk too much about like some of the stuff for like B-Sides Rochester is a local hacker conference that's been going on for more than a decade. Stuff that like we built a hackerspace like 10 years ago. Like I make references to it, but those are the things that I'm kind of proud of, is that there's been this like community in my little city of hackers, and I like to see these generation of hackers coming out of this city going on to do really awesome stuff. So I'm really proud of that. Wow.
Well, because that's the I guess for reference, that's a talk that's on YouTube from you as well, right? That's on B-Sides Rochester. There's a talk from you as well.
B-Sides Rochester, yeah. So it's been going on for a while, yeah, for sure.
Wow, there you go. I'm glad they are creating community for hacking for next generation as well. It's a oh no, Magno started in RIT. I don't know if that's the name.
Oh, for real?
Oh, yeah. There you go. Oh, there you go. So you guys need to hang out outside this as well.
Exactly.
Yeah. What's your last question? What's your favorite cuisine or restaurant that you can share?
Oh man, what's a restaurant since COVID? I've completely forgotten.
Oh yeah, like what are those things? Never knew that they existed.
No, my favorite that I always ask my mother to make me like on my birthday is like her handmade lasagna. So like that's my go-to. Like I can't beat it. And then I have to go run like 10 miles, like work it off, but like that's still worth it.
Great timing considering it's Mother's Day as well. So for everyone said, oh, like, did you just slip it in? So if your mom's listening to this, you like, she makes the lasagna.
I'm going to have to go teach her like what a podcast is first. And then
fair enough. Yeah. Like, but why do you spend so much time on audio? Like, but radio is fine. Yeah. What about television? Like, there's a video podcast option as well.
What channel is this on? Yeah.
Yeah. Would you please? Oh, so this is pretty good. Awesome, man. I think I'm going to say thank you, but I just wanted to say thank you to you as well. Thanks, Jeg. Thanks, Magno. Thanks, Tudo. Start tips on live description. I will do that, my friend. Thank you, Tudo. But I just want to say thank you, Mark. I had a great time. I learned so much, and clearly everyone over here learned so much as well. Where can people find you to basically hound you for questions after this?
Hey, find me on Twitter as Antitree. I'm happy to take DMs about all kinds of crazy stuff you got going on. So feel free.
Sweet. Raspberry Pi, Kubernetes, everything, like zero trust.
Zero trust.
There you go.
Let's do it.
If you guys are looking for social engineering, that's the way to go. This is zero trust. Actually, the social engineering would not have happened if there was a zero trust model. Just food for thought, right?
That's right.
But thanks so much. And thank you everyone else who joined us today. And we will see you all on the next week's episode, which you obviously have heard. Magno is coming next week. So I'm gonna make sure Mark is active and asking hard questions at that point. Sure. No pressure, Magno, but I will see you all next week. But if you haven't followed already, please follow Cloud Security Podcast on its, social media. That's where we go live every weekend. And otherwise, we'll see you next week. And I'll see you soon, Mark. Thanks so much, man.
Cool. Thank you, man.